this is a continuation of embedded Linux. So continuation of embedded Linux. So the previous videos, how to we had seen the basic commands in Linux, and how to write the shell scripts, and how to compile it, how to execute it. So how to make the shell scripts executable, and how to run the shell scripts, and how to write the C program, compile the program using gedit, and how to link and run the program in Linux. So in the previous videos we had discussed. So how in this video we will be seeing about how to debug the code, how to debug a C code using Linux. So GDB, it stands for GNU Project Debugger, and it is a powerful debugging tool for C. GDB stands for the GNU Debugger. So this is a powerful source level debugging package that lets you see what is going on inside the program. You can step through the code, set breakpoints, examine and change variables, and so on. It helps you to poke around inside your C programs while they are executing, and also allows you to see what exactly happens when your program crashes. So GDB operates on executable files, which are binary files produced by compilation process. So a.out remains the default output file name for executables created by certain compilers and linkers when no output name is specified. So how to debug a C program using GDB in 6 simple steps. So write a sample C program with errors for debugging purpose. Compile the C program with debugging option -G. So launch GDB. Set up a breakpoint inside C program. Execute the C program in GDB debugger. Print the variable values inside the GDB debugger and examine the values. So what are the types of error that might be happening in your code? So a bug usually arises from one of a small number of causes, each of which suggests a specific method of detection and removal. So if your program is incorrectly specified, it will inevitably fail to perform as required. So even the best programmer in the world can sometimes write the wrong program. So before you start programming, make sure that you know and understand clearly what your program needs to do. Especially in your embedded applications, you should clearly know what is your requirement and what your program needs to do. So you can detect and remove many specification errors by reviewing the requirements and agreeing that they are correct with those who will use the program. So in design errors, so programs of any size need to be designed before they are created. So there may be possible design errors will be there. So possible coding errors will be there. So everyone, it makes typing errors. So creating the source code from your design is an imperfect process. So that is where many bugs will creep in. So when you are faced with a bug in a program, don't overlook the possibility of simply rereading the source code or asking someone else to do. So you maybe detect and remove by talking through the implementation with someone else. So the 5 stages of debugging are testing, stabilization. So that is find out what defects or debugs exist. So making the bugs reproducible, that is what stabilization. Localization, identifying the lines of code responsible for the bug. Correction, fixing the code. Verification, making sure the fix works. So this is a sample C program with errors for debugging purpose. So this is a program to find the factorial of a number. So here this is the C code. So that is saved in the text editor. That is Vim text editor. So under the name factorial.c. So here we had initiated so that is I and j variables. So for I is equal to n, I is less than num, I plus plus, j is equal to j star I. So this is your factorial program. So now I am executing this typing this program using a editor, Vim editor factorial.c. Using the Vim editor I type the program and I compile the program using C compiler. So I didn't mention any that is file name for storing the executables. So defaultly the file executable binaries will be there, the compiled code it will be there in a.out file. So now I am running ./a.out. So now the thing is I want to find out the factorial of a given number. So that is factorial of the number. So it is asking for enter the number. So this 5 I am giving. So the factorial, if I am going to run, so this it should give factorial of 5 is 120, but it is giving 0. So now what is the bug, where the bug exists? So using the GDB debugger, so you can able to find out the fix the bug. So the how to use the GDB debugger in Linux. So first step 1 is compile the C program with the debugging option -G. So compile your C program, that is factorial.c, with the debugging option -G. Compile your C program with -G option. This allows the compiler to collect the debug information. So and invoke the C compiler passing the name of the source file. So -G option is used to include appropriate debug information on the binary executable generator. So the above command creates a.out file which will be used for debugging as shown below. So this is debugging. So now the step 2 is, so your step 1 is you have to compile the code with -G option, so that your debugging information also will be included in your executable code. So next step is launch the GDB session. GDB is an interactive session, so launch the GDB section. So GDB, so launch that is file, what is the executable produced by factorial.c, that is a.out. So that launch it. So now the GDB session is launched. So you can able to see in the screen these lines. So that is loading, reading symbols from a.out, and GDB session is started. So now you can set up a breakpoint inside the program. So where you are suspecting some error in the program manually, so you can put a breakpoint. While executing the program, the debugger will stop at the breakpoint and gives you the prompt to debug. So what is the that is a command for giving the breakpoint? It is you can give break line number or simply B line number. So GDB, so GDB session already started. You will launch a GDB session. The next step is in your that is your Linux. So you are giving this breakpoint. So the command B line number you have to give. So breakpoint 1 at line number 10 in the program factorial.c. So now you given the breakpoint. Now execute the C program in GDB debugger. Start running the program using the current run command in the GDB debugger. So also give the command line arguments to the program via arguments. Since this is a simple program, it does not require any arguments. So arguments is not given. So simply run the program in the GDB session. So now you can give breakpoints at line number 10 and run GDB run. Now start running. So it is asking for enter the number. So if you are giving number 5, it should give obviously result should be 120, but it is not giving. So now what is that at breakpoint 1, it is showing some error. So at line number 10. So line number 10, what is that? Line number 10 of the program. So the line number 10 of the program, it is j is equal to j star I. So in the program you can see that is j is not initialized. Okay, initialized to 1. So you have to initialize. So here you have to initialize with j is equal to 1. So that is the first debug. So so next one. So to step into the next, okay, next what is the bug? You can go for this step next continue or step. So GDB, yes, you can give, or GDB step you can give. So now again when it is giving, it is not giving the correct answers. Again it is giving at line number 9 some fault. So line number 9 is for I is equal to 1, I is less than num, so I plus plus. So here what might be the fault? So it's a factorial of a number. The given input number num, it is in the num variable. So you have to give I is less than or equal to num. So now again you are finding out. So now go ahead with the next execution. So next line. So again you are pressing the next. Again it is coming to the breakpoint 1. So these are all the debugs, possible debugs. That is one is j is not initialized. Another thing is in line number 10. So another thing is line number 9. So your I should be less than or equal to none. So now you are going back. So and so again you can also have another command, that is your backtrace command. So where is the probable, that is where it is stucking, so that again you can see it using the backtrace command bt. So GDB bt command you can use it for that. So now again to investigate function inside where program stopped executing at breakpoint. So where it is stopped executing at the breakpoint, use GDB step. To continue to debug the program, use GDB next. If the command is simply repeat of the previous command, just hit and enter G. After GDB, just plus enter. To know where you are in the program's backtracing execution, use GDB BT. So these are all the various commands you can use to find the debug. What are all the possible debugs in the code? So the step 5 is printing the variable values inside the GDB debugger. So in the factorial C, we have not initialized the variables j, so it gets the garbage value resulting in a big numbers as the factorial values. Now fix this issue by initializing the variable j with 1, compile the C program, execute it again. Even after this fix, there seems to be some problem. That is what the problem in line number 9. So that is your j should be, I should be, that is less than or equal to n. So main, so now you are printing the variables. What are the variables in the program? That is for printing the variables, what is the code? You can go for print or GDB p. What are the variable name that you have to give it? So p, I, p, j, p, num. These are all the variables. You are checking the variable. So that is first variable, that is I, this giving us 2. So that is j variable, it is given as 0. So here there is a false. So you have to correct these things. So continue stepping over and in GDB commands. So C or continue, that is debugger will continue executing until the next breakpoint. N or next means debugger will execute the next line as single instruction. Step means so same as next, but does not reach the function as a single instruction. So instead goes into the function, execute it line by line. So by continuing or stepping through, you could have found that the issue, because we have not used the less than or equal to in the for loop condition. So changing from less than to less than equal to, it will solve the issue. So this is how you will be finding out debugging a code using a GDB debugger in the Linux. So what are the steps? So you have to compile the C program with -G option. This allows the compiler to give the debug. So that is debug parameters to the binary file generated, and launch the GDB session, set up a breakpoints, execute the C program, and then so you can use either step, point, continue or next or back tracing, so that you can able to trace what are all the bugs. And then you can go for this printing the variable values. By examining the variable values also you can debug the code. So and then you have to go for correction and you have to run. So this is again another program with the bugs. So here in this program, so you will be having, so this is a, that is a structure that is of two data, that is a data and key. So that is structure, that is of array. So that is your data and key, that is data, it will be the name, and the key will be the number value. So based upon the key value, the array should be sorted out. That is your program. So here this program with bugs will be the segmentation fault. So here again using various techniques, that is your by code inspection and debugging with the GDB. These are all the some of the GDB commands. This and GDB commands you will be using, and examining variables, setting breakpoints, listing the program, patches. So what are all the breakpoint commands? Again there are set of breakpoint commands, it is listed here. So break, catch, clear, delete, enable breakpoint, disable breakpoint, ignore, or watch, or break. So these are all the things. So using that you can able to debug the